Hi, Chris Kuzmal here. Today we're going to explore binary search trees by example in order to understand how to find the smallest element in a search tree and how to find what's called the successor of a given element in a search tree. The only way you can access a search tree, a binary search tree, typically is to look at that is to be able to access the root. So if I want to find the smallest element in my binary search tree, I have to start at the root. And then what I do is I look to my left child until my left child is null. The left child of this root is not null, so I go left. Left child to that node is not null, so I continue left, and I continue on. The left child of that node is this here, no, down in the lower left, and it has no left child. Its left child, in other words, is null. So this is the minimum. Now we're going to count up. We're going to look at the successors from this smallest element. Well, what's the next larger element? If we just inspect it, we see that it's this 6. How did we get that? Well, that your successor is generally going to be the smallest element of your right subtree. That's the general rule. But there is no right subtree. So it's going to be the first ancestor for which that ancestor points to the left to get to you. Okay, well, in this case, that ancestor is my direct parent, which is 6. Okay, the same rule applies to find 6's successor. 6 has no right subtree, so we go up until we find a parent who is pointing to the left to get to us. And that only requires us to look at our immediate parent because our immediate parent looks to the left to get to us. What's 8's successor? 8's successor is the minimum element of its right subtree. If that right subtree exists, it does exist. The right subtree's minimum element is going to start at the root of that subtree, which is 9 in this case, and we look left until we hit null. Well, we immediately hit null, so 9 is the minimum of its own subtree. Similarly, 10, so the successor to 9 will be the minimum in its subtree, which is this teeny tiny subtree here, which is just this one node, 10. Here's where it gets a little tricky. We've articulated how you find the successor in this situation, but it's a little harder to fathom that 11 is the successor to 10. The reason it is we're going to look at ancestors repeatedly until we find an ancestor who points left to get to us. So we're saying, I'm looking for a parent who pointed left to get to me. Well, 9 pointed right to get to me, so no. Keep looking for a parent. Next parent pointed right to get to me, so that's not it. The next parent pointed left to get to me. This is my successor, where I was 10, okay? Now then, successor to 11 is going to be the minimum of the element in its right subtree. So it's starting to become repetitive, which I'm hoping is helpful. The minimum within this subtree is going to be that we keep looking to the left until there's nowhere left to look. That's going to be element 13 is the successor to element 11. What's the successor to the element 13? It's the minimum of its right subtree. It exists, that subtree does, so it's 14. What's 14's successor? The first ancestor that points left. So I look up my ancestors, and that's 15. And that's 15. What's 15's successor? 15's successor is the minimum of the right subtree, which has got to be the element, in this case, of the root, because this root of this subtree has no left subtree. Now, I at first was going to correct this mistake that I made of blocking off this node here to with my picture, but I think it's a useful point to say I still know what the successor to the element in the right red triangle, the successor to the element with key 90 is got to be whatever this guy is. I don't know what it is. The triangle appears around it, but I know that it is the minimum within the right subtree, and the minimum within the right subtree, well, there's only one element in that right subtree. So whatever that is, even though I can't see it, I know that's the value to return. So that is a traversal of a binary search tree, and that therefore will inform our ability to write the code for finding the minimum, the maximum, and what's called the successor, and ultimately for being able to do deletion for binary search trees.